Okay, so hello everyone, welcome to another video on this channel, and thank you so much for the support on my previous video. This video we're going to be learning about functions. Now at the end of the video you should understand how a function operates, ways to define a function, and how to identify a function when you see one. So without further ado, let's move forward. Okay, so a function can be thought of as a machine in a box that is open on two ends. You put something on one end of the box, it gets changed inside of the box, and then the result pops out of the other end. So now you have a very large box, which is this, and then you have, let's say, two holes, one at the top of the box and one at the bottom of the box. So you have a very useful machine, which is the function inside that box. So now once you put acceptable input values, the machine transforms those input values and then produces the output, which comes out from the other side of the box, which is the bottom part. So let's look at what a function is made up of. Okay, so a function is made up of inputs and outputs. So the input is any acceptable value that is inserted into a function, and the set of input values is regarded as the domain of that function. So now functions have a particular set of input values in which they can be defined on. Now you just don't pick any value which is not in that domain and put inside that function. You won't get a resulting output. So there are sets of acceptable values in which when you put inside that function you get a resulting output value. So now let's talk about output. The output value is the result gotten after the input value has been inserted into a function. So now once you put that acceptable input value, you get a resulting output value. Now the range can be seen as the set of output values. So an output value basically comes from the input value, and then the range can be seen as those sets, or that set rather, which contains all the output values or only the output values of that function. Okay, so before we move to another definition of a function, let's look at the real number line. Okay, so the real number line consists of integers, rational and irrational numbers. That is this line over here. Now integers are whole numbers that can be positive, negative, or 0. So now example of integers are 5, 2, minus 5, minus 2, 0, 1, 2, and so on. So now example of numbers that are not integers are minus 1.43, 5.4, just basically any number that is not a whole number. So let's look at what rational numbers are. So now a rational number is any number that can be written in the form a over b, where a and b are integers. So now a and b take values from these sets of numbers, integers, and now b must not be equal to 0 because division by 0 is not defined in mathematics. So examples of rational numbers are 2 over 3, 4 over 5, 6 over 3, which can still be 2, and let's use another example like 5 over 6. So let's look at the last section, which is irrational numbers. Now irrational numbers are basically numbers that are not rational. That is, numbers that cannot be represented in this form. So numbers like that include pi, which doesn't actually have an end yet, 3.141, and so on. And we have root 2, we have the cube root of 3, and basically numbers that cannot be written in the form a over b. So now do note that for rational numbers I can also say something like 0.5, because 0.5 can be written in the form which is 1 over 2, which is the form a over b. So there are some decimal numbers here that you can actually write in the form a over b and actually call rational numbers, and there are some which are irrational numbers that cannot be written in this form a over b. So take note. So let's look at another definition of function. Okay, so another definition of a function is that it is a rule that relates two variables x and y such that for each value of x, note that x is actually the input value. So for each value of x, we have one and only one value of y, which is the output value. So you put in an x value, which is the input value, and the function assigns it to one and only one value of y. Now take note of that, one and only one value of y. If you put an input value into a machine and you have two output values, it's actually kind of weird. So you put in an input value and you get one value of y. So that's what's called a function. So the proper way of writing that is f takes values of a and maps it into values in b. So now a is the domain of the function, and we said that the domain is the set of acceptable values of a function. So now b is the codomain. Now codomain is the set into which all the output values of a function is constrained to fall. Now to understand better, codomain actually just tells you what kind of objects the function produces without actually having specific knowledge of the range. Remember that we said that the range is the set of output values. So the codomain just tells you what the object should look like, or what it should fall inside, without actually having specific knowledge of what the range is. So more like you can see it as the codomain as telling you that, okay, this is what your output should look like, or yeah, something like that. So by understanding this, let's look at some examples of finding the range and identifying if that is a function or not. Okay, so we're going to be solving the first problem, and then in this problem we're going to be finding the range of f. Now remember that the range is actually the set of output values, and in order to get your output values, you need to insert each input value into the function and get the resulting outputs respectively. So now at the end of this problem, we're going to notice that the range is going to be a subset of the codomain, which we have here as R. Now, for it to be a subset means that every value that set contains is also contained inside the codomain. So if I say the range is a subset of the codomain, I mean that every value in that range set is always going to be contained in that codomain. So let's see if we can solve this problem. So we have our input values, and which is the domain here, and this is the set containing it. So that is 0, 1, 2, 3. So our function is f of x is equal to 2x plus 3. So in order to get our output values, we're going to put each input value inside this function. So at x equal to 0, we're going to have that f of 0 is equal to 2 into 0 plus 3, which is equal to 0 plus 3, because 2 times 0 is 0. So 0 plus 3 is 3, and f of 1 is going to be 2 into 1 plus 3, which is 2 plus 3, and this is easily 5. So the next one is 2. So f of 2 is equal to 2 into 2 plus 3, which is equal to 4 plus 3. This is 7. And finally, our last input value is 3. So f of 3 is equal to 2 into 3 plus 3, which is equal to 6 plus 3, which is equal to 9. So you can see that these are the output values we've gotten. So that means the range will be equal to 3, 5, 7, 9. And notice that it is a subset of the real number. Now, remember that real numbers contains integers. So remember that 3, 5, 7, and 9 are integers. So let's see another example. Okay, so for the second problem, we're going to be solving this. See the same with the first one. We're just going to find the range of f. But first of all, I'd like you to pause this video and try it yourself. Find the range of this function with this domain we have here, and also try and see if this is actually true. Like, is this true that this is a function? And maybe try and give yourself reasons why this is so. And also confirm if your range is a subset of the codomain. Okay, so let's solve this. The first thing to do is to write down your function, which is f of x is equal to x over 2. And then we have our input values 2, 4, 6. So we're going to put each of them inside the function. So f of 2 is equal to 2 over 2, which is equal to 1. F of 4 is equal to 4 over 2, which is equal to 2. And lastly, f of 6 is equal to 6 over 2, which is equal to 3. So we have our respective output values are 1, 2, 3. So our range is going to be the set of those output values, which is going to be 1, 2, 3. And notice that it is contained inside our codomain, which is R. Now, this is a function because each input value gives one output value only. 2 gave 1, 4 gave 2, and 6 gave 3. So let's look at an example that involves the opposite. Okay, so the third example says we should consider this over here, defined by f of x is equal to plus or minus root x. So the question is this a function? So now remember that we said a function is a rule that assigns each input value to exactly one output value. So let's see if we can confirm that. So let's write our function first. The first input value we have is 4. So f of 4 is going to be plus or minus root 4. The square root of 4 is going to be 2. So this is plus or minus 2. F of 1 is going to be plus or minus root 1, which is going to be plus or minus 1. F of 9 is going to be plus or minus root 9, which is going to be plus or minus 3. F of 16 is going to be plus or minus root 16, which is equal to plus or minus 4. So after what we solved now, do you actually think this is a function? Like we have each input value giving us like 2 output values, which is actually not what we want. We want each input value to give us exactly one output value. So we can say that this is not a function. So the question remains, what if this is, let's say it's only one input value that gave 2 output values and the rest gave exactly only one output value? We still consider that to be a function. So the answer to that question is no. Remember, a function is a rule that assigns every input value to exactly one output value. So if one of them assigns to only two output values, then that is not a function. So take note of that definition. So let's look at another definition of a function. Okay, so the final definition in this video is that a function is a set of ordered pairs in which no two different ordered pairs have the same x coordinate. Now by ordered pair I mean something like this, x comma y. So most times when we plot graph, we are given points on the graph 2, 1, 3, 2, and so on. So in terms of a function, we know that this is the input value x and then this is the output value, which is y. Most times it's called f of x depending on how the textbook or the teacher uses it. So now we're going to be looking at examples that involve arranging functions in ordered pairs and then telling if a set of ordered pairs is actually a function. So let's go ahead. Alright, so the first example says, suppose we have input values a is equal to 2, 4, 6, 8. So a is our domain and f of x is equal to x over 2. Write the function as a set of ordered pairs. So basically we want to write it in the form x comma f of x. So we're going to put each input value inside the function and then write it like this. So let's start with 2. So at x equal to 2, f of 2 is going to be 2 over 2, which is 1. At x equal to 4, f of 4 is going to be 4 over 2, which is 2. At x equal to 6, f of 6 is equal to 6 over 2, which is 3. And finally, at x equal to 8, f of 8 is equal to 8 over 2, which is 4. So we just need to pair this. So we have that 2 gave 1, so this is going to be 2 comma 1. 4 gave 2, so this is going to be 4 comma 2. 6 produced 3, so this is going to be 6 comma 3. And finally 8 produced 4, so this is going to be 8 comma 4. So we said that a function is a set of ordered pairs in which no x coordinates give the same and give two output values rather. So we have that no x coordinates, which is this produces two output values rather. So let's write our function as a set of ordered pairs. So f will be equal to 2 comma 1, 4 comma 2, 6 comma 3, and lastly 8 comma 4. So this is our function. So let's look at another example. Alright, so the next example says we should determine if the set of ordered pairs is a function. So we have 3 comma minus 4, 2 comma 3, 4 comma 5, and lastly 6 comma 7. Now in mathematics, the most important thing you should hold very well when you start a topic is its definition. So now our definition says that a function is a set of ordered pairs in which no two different ordered pairs have the same s coordinates, and by s coordinates I mean this guy here, this guy here, this guy here, and lastly this guy. So how do we go about this now? We see that for each s coordinates we have only one output. 3 gave minus 4, 2 gave 3, 4 gave 5, and 6 gave 7. So this is a function. So we can actually say yes. So the last example says determine if the set of ordered pairs is a function. So we have 9 comma 3, 4 comma minus 2, 9 comma minus 3, and lastly 4 comma 2. So we have this s coordinates 9 producing 3, and we also have 9 producing minus 3, which is wrong. We have 4 producing minus 2 and also have 4 producing 2. So you can see that we have two different ordered pairs producing the same, having the same s coordinate. So this is not a function. So you can see that to understand which one is a function, you just need to hold on to your definition. A function is a set of ordered pairs in which no two different ordered pairs have the same s coordinate. So we have 9 comma 3, 9 comma minus 3. They are two different ordered pairs, but then they have the same s coordinate, which is 9, 9. We have 4 comma minus 2, 4 comma 2. Two different ordered pairs having the same x coordinate, which is 4 comma 4 and 4. So this is not a function. So thank you for watching this video. I don't know if it was helpful. If it was helpful, you can help me like, share, and subscribe. Drop a comment on the comment section, and do follow our Facebook page. The link is in the description, and there will be a question posted there to test if you actually understood what we did here. Thank you for watching.